Hello guys, welcome to another video from HDI. Today's topic is relatively new, CCTV and cameras. First time we introduced CCTV object in the software was about a year ago, and we recently added new features. That's why we wanted to bring this to a video and then show to our clients. So let's get started. Now, where do we use cameras? And why is it interesting to us? So cameras are used in the mining industry. It's used in the border areas, or used in the coastal areas, used in important infrastructure like oil and gas facilities, used in airports, for example, as well, in the anti-drone system, in order to detect drones and objects. So camera is becoming increasingly useful object in these domains, and we decided to kind of add these capabilities to our software in order to make it more diverse and more comprehensive. So the main importance of bringing our software to the camera modeling is the idea of modeling terrain and clutter and building layers. So that's the added value that our software can add, is the reality that we can actually capture digital terrain area. So we can model the terrain obstructions, we can model the clutter, so the different objects, materials, vegetations that we come across in the environment. And also, most importantly, is that we can model the building layer. Okay, so here's the building layer. Let me just remove this viewing. Adaptive. All right, here you go. So you can see, guys, we can model the canopies for the vegetations. We can model the building structure. We can define different elevation information. So all of this information can be really crucial if you want to understand the visibility of the camera. So this is the environment that we're going to use for the modeling and simulation. So now let me introduce you the camera object. How do we add a camera object? So to add a camera object, I'm just going to choose a location for now, maybe here, somewhere around here. I'm going to go right click here, add a station, and instead of adding a regular TXRX station, you add CCTV object. So this is a CCTV object or configuration. So here we can put the height of the camera above the ground level. So let's say this camera is going to be positioned 30 meters above the ground, and is the orientation of the camera. So let's say the camera is oriented about 80 degrees north. So this is 0, this is 90, this is 180. And this is roughly 270. So 280 will be pointing roughly this way. And tilt, if you have any tilt done for the camera, for example 3 degrees down or 5 degrees down, so negative here means downwards. And the view angle, so this horizontal view angle is actually half the horizontal view angle. So let's say the camera is 120 degrees wide, 120 degrees, or maybe 160 degrees. All right, so if it's 160 degrees wide, so half of it, it would be for example 90. So 90 is you multiply 90 by 2. This is 180 degrees. Okay, so if you want it to be 160 degrees, for example, then you would go with 85 degrees. This is half of it. This is the horizontal angle. This is the vertical angle. Let's say the vertical angle of that camera is maybe 45 degrees. Let's say. So 45, so you divide by 2. So 20, let's say 23 degrees. So this is my cam 1. So that's pretty much it. So there's not too much configuration here. The horizontal angle and the vertical angle will allow us really to understand the focal length of the camera. So there's two ways to model cameras. You can use the focal length, and you can use the aperture of the sensor, or you could use directly the horizontal and vertical angle. The resolution will be used elsewhere. So that's the first object here. Now we have here one object. So I'm going to make two more. two more cameras, duplicate the cameras, two more copies, and 120 degrees off. I'm going to use exactly the same parameters, so I'm going to keep them. So here we go. That's my first camera location. So I've got 3 cameras effectively here. So how to analyze the camera coverage? So all you have to do, you don't have to choose any propagation model. You don't have to play with your settings. All you have to do really is just right click, go to the coverage, and then CCTV camera coverage. You click on the CCTV coverage, and here we have a range of settings. So here we can decide what source you want to use for the analysis, what camera you want to use. So if you want to use the cameras you have on the map, you just go to sources are activated CCTVs. That's it. So if you choose that option, you don't need to worry about the rest of the options here, which means that the function will use these cameras as input to the analysis. Now if you choose to go with a point, that's where you did the right click. Okay, so if you want to right click and analyze specific position quickly, there could be a handy way to do the analysis quickly without configuring the camera. So I'm going to use my CCTV as a source, and now here on the right we've got a range of analysis of functionalities that we could use. A target height is important, so the target you're trying to detect, let's say if it's a person, then you could go with 1 meters. If it's a flying target, then you would go with, for example, 200, 300, 400 meters, depending on the target you're trying to achieve. So here we have intervisibility analysis, a composite map, best camera, and so on. So the one which is really interesting for me is the DRI map. DRI stands for detection, recognition, and identification. This function will give you 3 coverage interpretations here. So that's one camera here in the middle. So the camera will give you a green color, a blue color, and a yellow color. So the yellow color is the detection, which means the camera can detect something, but you cannot make sense of it. You can detect there's a movement, there's something there, but you can't tell, is it really a person, is it a dog, is it a drone, is it a car? You can't. So it's far away, and the camera can only detect something. Now when the object is in the blue area, so here the object can be detected and also can be recognized. So recognized means you can tell this is a person, this is a male, this is a female. So you can tell what is this. It's a person, it's a dog, but you cannot really exactly point out who is that person. Let's say you have a database of people working on the facility. You cannot really tell exactly who is that person. You can't see his face clearly. Now when he's moving in the green area, that's when you can really identify the person. So that's DRI. So if I run this function now, this function requires from me distances. Okay. Now this feature is recently added. So is asking the software what is the range. Obviously you don't know the range. You want a tool to tell you what the range is. That's fine. So here we could use the calculator here, the distance calculator, to calculate based on the resolution of the camera and based on the target you're trying to achieve. So in our example here, in our documentation, we explain what is the density that we are expecting. Here. So with let's say you want to target 90% confidence. Okay, so with 90% confidence, you want to really be confident with your detection and with your recognition and identifications. So you would need roughly 3 pixels to reach the detection range. 3 pixels. Okay, so I'm gonna go here. This is my resolution of my camera, 1920 by 1080. And let's say here detection, I'm gonna go with we said we're gonna go with 3 pixels, and the camera is, let's say 160 degrees by 45 degrees. So this is telling me that the detection range is 649. So I'm gonna take note of this. So detection is 649 meters. And now we move on to here. I'm using 90% confidence, and here 11 pixels. So I'll go again to calculator, and this time use here 11 pixels. Sorry, not here. So that dropped to 177. So the recognition is 177. Now identification, according to the document we need here, is 21, roughly 21, let's say 22 pixels per meter. So that dropped to 88 meters. Okay, so that camera has these ranges. So I'll go back here, and then we 664, let's say 650, followed by 177, followed by 88. It has to be the other way around. 88, and then 177, and then 649 or 650. Alright, here we go. So now the software predicted these three colors. Now here in the vicinity of the site, because the camera is only 45 degrees and because it's a 30 meter height, you have no visibility immediately under the site. Okay, that's understandable, and you can really take care of this by changing the vertical orientation, or the vertical view angle. So here we have three colors. So now if you have an object in the green area, it would be detected but not necessarily identified or recognized. Now you can add more cameras. You can go like this, stations, copy paste. Let's say you want to put a camera here, you want to put a camera there, here, and let's say another one here. So you can go like this, coverage, CCTV camera, and run the analysis, and now the software will give you that composite map. Okay, so the concept here is based on this. So what the tool is doing here, the tool is predicting value 1, 2, and 3, and it will always choose the lower value. So obviously the identification is better than the detection, better than recognition, and recognition is better than detection. So the software will always show you the green when it is possible, or the blue, and then the yellow. So that's what the coverage look like. Now say you want to find an ideal location to deploy a camera to have a visibility over a certain area. Okay, doing site search. So let's say I want to search the area here. I want to deploy somewhere here a camera, but I don't know what is the best location. So you can do searching for site, and let's say the target is 1 meter height, and then the camera will be 3 meter height. So you can go and do the analysis. And if the camera, the radius of the camera is no more than 0.6, the detection, just put 0.6. That's pretty much it. Now we run the function. So this is producing a heat map. Here you go. So the software now is giving you a heat map with a confidence level. So the hotter the color, the better the location. So if I put the camera in a green area, it will be only achieving something around, let me just default the color for a second. So if you put it in a blue or a green area, you will have low percentage. So the camera will not have good visibility over the area. If you decide to put it in the brown area, that's when you have the best performance out of this camera. So obviously the one camera will only be able to cover 50% of the area, not the whole area. So anyway, I'm going to choose that location. So if I put it here in that brown here, or maybe that brown here. This is 55%. That's a good percentage. So right click, add a camera, or you can just copy paste the camera from another location like what we did before. So you got a rectangle like this, stations, copy paste. You can zoom in. Stations, copy paste, and this is 55. Here you go. So that camera is expected really to solve only 55% of the area. So coverage, CCTV. So CCTV is a source, DRI, and hit OK. So here we go. That's the coverage we achieved. Now obviously you need a bit more. You need one probably here, so you can do the search again. So this is, guys, what I wanted to show you. The 3D view. Alright guys, so this is pretty much what I wanted to show you. So if you guys have any clarifications or any questions, or if you're interested in the product, feel free to contact us and we'll assist you. Thank you.